Hello everyone, Mr. Schultz here for Integrated Math 1, and we're dealing with two-dimensional figures. So once again, we're dealing with two-dimensional figures. Don't forget to put your first and last name on your paper as well as your period number. One final time, we're dealing with two-dimensional figures. So let's go over some basic vocabulary. So when we're talking about two-dimensional figures, one of the first things we're going to talk about is a polygon. Now, I'll be honest with this. Now, a polygon is multiple, and I've said this before, it's sided, but no, it's multiple angles. So a polygon could be a triangle. A polygon could be a square. It just depends on how many angles are we talking about. Poly being multiple or many angles. Now we have perimeter. Now a perimeter is, we could say this, is around. Now peri is going to be around an object. So let's write that now. Around an object. Alright, this should be fixed on yours, but this is going to be, I'm going to take this off for right now. If it's not fixed, go ahead and cross it off. So, perimeter, peri being around an object, and meter being the distance or length. So, perimeter is, so if we had an object, the perimeter is the distance around an object. Let's go on. Circumference. So the circumference is the distance around the circle. So if we have a circle, it's the distance around the circle. So remember, circumference is equal to the diameter times pi. So pi times the diameter would equal the circumference. Area, the number of square units needed to cover a surface. That's it. So if we had a square or a rectangle, that's pretty easy. We could be like, all right, we understand there's this many. If we had a triangle, it might be a little bit harder to figure it out. Hence why when we're saying, hey, the area is length times width for a rectangle, the area of a triangle will be 1/2 times length times width, because there's a missing half to this triangle for a quadrilateral right here, or a parallelogram. So equilateral polygon. Let's hold up. So when we have an equilateral polygon, all sides are congruent. So let's put that out. So we could have a triangle that all sides are congruent, or if we could have a square that all sides are congruent, or a, what was it called? Not a kite. I'll think about it in just a second. Oh yeah, a rhombus. There we go. All right, let's continue. The final was an equal angular polygon, that all angles are congruent. Well, on this, we'll see that like, hey, look, all the angles are congruent. Well, and we'll see this mainly when we're dealing with regular polygons, when we have both sides and angles are congruent. So if we had a regular polygon that's a triangle, all the sides are congruent and all the angles are congruent with each other. And so that's a regular triangle. Or we could have a regular hexagon or a regular polygon. It just depends on how many angles we're going to have, and then we would name it as such. All right, let's go on. So, triangles, rectangles, and circles. So, if we're dealing with a triangle, we have to figure out, when we're dealing with the perimeter, we'd have to figure out the length of each of the sides. So this X, this Y, this A, we'd have to add them up. We'd have to figure out what is each one. Sometimes we could figure out by just counting, and other times we're going to have to use the distance formula. Now the area is equal to the length times the height, but multiplied by 1/2. Now for rectangles, that's going to be length times width. But the perimeter, so for the triangle is x plus y plus a. The perimeter on this one would be 2 of the lengths plus 2 of the widths. Now finally for the circle, the perimeter, remember the perimeter is equal to the circumference, which is the diameter times pi. So once we figure out what the diameter is, times the pi, you got the perimeter. Now the area of a triangle, if you remember from your 6th grade class, is equal to pi r squared. So the key is you need to figure out what is the diameter. Once you figure out the diameter, you can figure out the perimeter divided by 2, and then you can figure out what is the area by doing pi r squared. There you go. All right, guys. Well, let's jump and do 1, 2, and 3 in 3, 2, 1. All right. So example 1. Find the perimeter and circumference and area of each figure if each unit on the graph measures 1 centimeter. Round the answers to the nearest tenth if necessary. Well, the first thing we have to do is find the perimeter. So understanding this, I know this is 1, 2, 3, 4. So the perimeter is equal to 4 plus, well, let's figure out the other one. 1, 2, 3, 4, 5, 6, 7, 8. 4 plus 8. Now this is where we get into the tough part. We have to figure out what is BC. Well, we'll get to that in just a second. So the area would equal 1/2 4 times 8. And figuring this out will be a whole lot easier than the perimeter, which would be 16 centimeters squared. Because half of 8 is 4, 4 times 4 is 16, but it's centimeters, so centimeters times centimeters is centimeters squared. Well, now we have this, what is BC? So the perimeter is equal to 12 centimeters plus whatever BC is. Well, we have to figure out what BC is. So the distance is going to be the x minus the other x squared plus the y, so it's 9, minus the other y, 1 squared. Now we get 4 squared plus 8 squared and the square root of it. 4 squared plus 8 squared is 16 plus 64 squared. And 16 plus 64 is 70, 80. So the square root of 80. Now you might be thinking, well, how do we get that? Well, I'm going to give you a big ol' hint in just 3, 2, 1. And the hint is you have to use a calculator. So looking at this, the square root of 80 is going to be 8.94. So it says nearest tenth, so that's 8.9. So BC is equal to 8.9. But wait, that's not the answer. The answer was 12 centimeters plus 8.9. So the perimeter is equal to 12 plus 8, 20.9 centimeters. And so here's our two answers. What is the perimeter? What is the area? Let's go on to the next one in 3, 2, 1. All right, so let's continue. Now we're dealing with a rectangle, but it's not easy to read. So if it had been easy to read, we could do length times width and like just do counting. But looking at this, we're going to see that, hey, we don't have it. So we have to use the distance formula. And so let's do it. So we understand that the area will equal the length times the width. We understand that the perimeter will equal 2 of the lengths plus 2 of the widths. So, I don't know, it just depends on what we want to call it. We could say, hey, this one's the length and this one's the width, or we could switch it back and forth, but it doesn't matter. So let's do this. So I'm going to use the distance formula twice. I understand that the distance is the x minus the other x. So I'm going to do AD. So this is AD squared plus the y. 7 minus the other y squared. So this is AD. Negative 2 plus 4 is 2. Squared is 4. 7 minus 3 is 4. Squared is 16. So we're going to have to find the square root of 20. So AD is equal to the square root of 20. Well, getting out my handy dandy calculator, the square root of 20 is equal to 4.5. So AD equals 4.5. Now the next one is going to be AB. So I'm going to say, hey, AB is equal to negative 2 minus 4 plus, and squared, plus 7 minus 4 squared. So negative 6 squared would be 36, and then 7 minus 4 is 3, squared would be 9. So we're going to have to find out what is the square root of 45. Taking out my handy dandy calculator, I do the square root of 45, and I get 6.7. So AB equals 6.7. Well, now I just need to do 4.5 for the area. I do 4.5 times 6.7. So I go 4.5. I get 30.2. All right, cool. So 30.2 centimeters squared. Now the other one, I times it by 2, and then times this by 2. So the perimeter would be 9 plus 13.4. 9 plus 13.4 would be 22.4 centimeters. How did I get that? Well, I just plugged it in. 2 times the length plus 2 times the width. And that's our perimeter. All right, last one. Looking at this, I see that it goes 1, 2, 3, and 6. So I know that the circumference, our perimeter is equal to circumference, and that's equal to d times pi. I know that my area is equal to pi r squared. So my radius is 3, number 7, 8, and 9. So what is this asking? It's the exact same thing, but you have to figure out what shape are you going to do. So looking at this, it's going to be, hey, it's a circle. So the perimeter is equal to the circumference, which is equal to d pi. What about this one? Well, the area is equal to pi r squared. Now going on, we're like, oh, it's a flag, or not flag, sail. Which shape does the sail have? Well, the sails have, side 1 plus side 2 plus side 3 will equal the perimeter. But the area is 1/2 base times height. And going on, now you might be like, wait a second here, there's no height. Well, technically, here's our base, and then here's our height. So the base of 14 feet 7 inches, and then the height of 11 feet 2 inches. Now, the problem is you have to convert it to all of it to inches. All right, let's go on. All right, guys, before we go on, what shape do you think this is going to be? I'll draw it out for you. It's a rectangle. Not a very nicely drawn one, but I believe in you, and I want you to try your best. Remember that the perimeter is equal to 2 times the length plus 2 times the width, and the area will equal length times width. All right, good luck, guys. I'll see you in class, and I hope you have a wonderful day. Bye, everybody.